Hi there, it's Miss Dowey, and this is the lesson 7.3 using the double angle formula. Make sure that you already know the double angle formulas. In this first example, we're given sine theta is negative 5 over 13, and we're also given the quadrant for the angle theta. We're asked to find 5 different trig ratios, and these need to be exact values. So what we're going to do first is we're going to use Pythagorean theorem and SOHCAHTOA to find the value for x. It turns out that x is negative 12, and that's because it's in quadrant 3. So since we have x is negative 12, and y is negative 5, r is 13, see if you can write down the 3 trig ratios, sine theta, cos theta, tan theta. Now you can check if you got them right. The first question is to evaluate sine of 2 theta. So see if you can write down the formula for sine of 2 theta. Once you have that, go back and look at which ratios we wrote for sine theta, cos theta. Substitute them in, and then multiply. Final answer, 120 over 169. Next question is a reciprocal trig, secant. So what is it the reciprocal of? It's the reciprocal of cos 2 theta. Now there are 3 different formulas. I'm going to use the one that uses sine theta because that was the ratio we were originally given. So the formula is 1 minus 2 sine squared theta, and that means that the sine theta has to be squared. The ratio for sine theta we were given, negative 5 over 13. So we square that, multiply it by 2, subtract it from 1. First of all, the squaring gives us 25 over 169. Multiply by 2 gives us 50 over 169. Get a common denominator, subtract, and finally multiply by the reciprocal for the final answer, 169 over 119. Next question is tan 2 theta. See if you can write down the formula for tan of 2 theta. Once you've got that written down, you need to look back at the ratio you found for tan theta. The ratio was 5 over 12. When you plug that in, all you have to do now is simplify using BEDMAS. So make sure you square the 5 over 12 before you subtract it from 1. So 5 over 6 divided by 1 minus 25 over 144. The bracket, you need a common denominator. Can't do division, you multiply by the reciprocal. Reduce the 6 and the 144. Final answer when you multiply is 120 over 119. Next question is cos 4 theta. Now 4 theta is pretty big. 4 theta is twice as big as 2 theta. So we're going to use the double angle formula for cos, but it's for cos 4 theta, so it's 2 cos squared 2 theta minus 1, because 4 theta is twice as big as 2 theta. But remember, that means that cos 2 theta has to be squared, and I'm using this version because we found a few minutes ago secant of 2 theta. So if we flip that back, we'll have cos of 2 theta. And cos of 2 theta is 119 over 169. Now I guess you'll need a calculator for this because you have to square it, multiply it by 2. And now you need a common denominator. Subtract, and you have your final ugly answer. This next one is kind of tricky because it's theta over 2, or half as big as theta. But we do know cos of theta from earlier, and we know the double angle formula. So we're going to change the double angle formula. Cos 2 theta, we're going to change it to a double angle formula for cos theta. It's still a double angle formula because theta is twice as big as theta over 2. So we're going to substitute negative 12 over 13 on the left, and we have to solve for sine theta over 2. Kind of tricky, so pay attention. So negative 12 over 13 is on the left, and what we're solving for is in the bracket on the right. I'm going to switch things around so that I don't have so many negatives. So I added 2 sine theta over 2 squared, and I added 12 over 13. So I need a common denominator on the right, and now I need to divide by 2. Now when we square root, we normally write plus or minus, but we have to figure out, is it plus or minus? Is it positive or negative? If we're given the quadrant for theta, then we can easily divide everything by 2 to figure out the quadrant for theta over 2. It turns out that it's quadrant 2, and sine would be positive in that quadrant. We now know our final answer should be positive. Take the square root of 25, which is 5, and rationalize the denominator. Okay, we're ready for example 2. Now this one we have to find the exact value of cos 9 pi over 8. Kind of looks like a question from yesterday, but the denominator is different. The denominator is 8, and I'll tell you right now there's no way that you'll be able to split that angle up into an addition or subtraction of special angles. So the only way that we can do this is we have to look at 9 pi over 8 as being theta, and we have to find 2 theta. So if theta is 9 pi over 8 and we double it, we get 9 pi over 4, which is really cool because 9 pi over 4 is one of the special angles on the unit circle. So let's use our double angle formula, and let's put in 9 pi over 4 for 2 theta and 9 pi over 8 for theta. But be careful, what you know is the value on the left because that's from the unit circle. I'm hoping you know cosine of 9 pi over 4, and then you have to solve or isolate the bracket on the right. Okay, so cos of 9 pi over 4 on the unit circle is root 2 over 2. So to isolate the bracket, the steps are add 1 first, divide by 2, and then square root. So add 1, you'll need to get a common denominator. Divide by 2, that'll make the 2 on the bottom turn into a 4. And then square root, we have that problem again, should it be plus or minus? Well, it turns out that 9 pi over 8, if you think about where that is, that would be in quadrant 3, so cosine should be negative. So again, the answer is negative because the angle is in quadrant 3. 9 pi over 8 is in quadrant 3. Last example, if we're given tan x is 4/3 and we're given the interval for the angle x, to find the value of tan of half x, or x over 2. So we are going to use the double angle formula, but we're going to change it from the version that you've memorized. We're going to change it to tan x equals 2 tan half x over 1 minus tan squared half x. Since we're given tan x is 4/3, we plug that in on the left. Now we have an equation to solve, which kind of looks ugly. So what we're going to do is we're going to let a replace the tan of x over 2, just so it looks a little bit better. And now it actually looks so good you can probably try it yourself. So take a moment, pause the video, see if you can solve for a. So we're going to cross multiply, divide both sides by 2, expand on the left, and it's a quadratic equation, so you have to get everything over on one side. Once you have everything on one side, you can factor, and you have the 2 factors, so you set each factor equal to 0. But that's kind of weird. How do you end up with 2 different answers? We have to figure out if the answer is a half or if the answer is -2. So going back to the quadrant, if x is between pi and 3 pi over 2, then half x is between pi over 2 and 3 pi over 4. That means the angle's in quadrant 2, and if the angle's in quadrant 2, tangent is negative. So final answer, tan of x over 2 is -2. Thanks for following. Good luck.